it is time to take a look at security. In this module, we will introduce AWS Security, explain what is the AWS Shared Responsibility Model, how to control and manage access to AWS services in your account, and some of the security resources and features available on the AWS platform. Introduction to AWS Security. AWS delivers a scalable cloud computing platform designed for high availability and dependability, providing the tools that enable you to run a wide range of applications, helping to protect the confidentiality, integrity, and availability of your systems and data is of the utmost importance to AWS, as is maintaining customer trust and confidence. This module is intended to introduce AWS approach to security, including the controls in the AWS environment and some of the products and features that AWS makes available to customers to meet their security objectives. All AWS customers benefit from a data center and network architecture built to satisfy the requirements of our most security-sensitive customers. This means that you get a resilient infrastructure designed for high security without the capital outlay and operational overhead of a traditional data center. The AWS infrastructure puts strong safeguards in place to help protect customer privacy. AWS innovates rapidly at scale, continually incorporating customer feedback into AWS services. This continual improvement benefits all customers because AWS solutions improve over time, including constantly evolving core security services such as identity and access management, logging and monitoring, encryption and key management, network segmentation, and standard DDoS protection at little to no additional cost. You also get advanced security services invented by engineers with deep insight into global security trends, allowing your team to proactively address emerging risks in real time while paying for only what you use, all at a lower cost. This means you can choose the security that meets your needs as you grow, without upfront expenses and with much lower operational overhead when compared to managing your own infrastructure. A properly secured environment helps to create a compliant environment. When you migrate your regulated workloads to AWS Cloud, you can achieve a high level of security at scale by using our many governance-enabling features. Cloud-based governance offers a lower cost of entry, easier operations, and improved agility by providing more oversight, security control, and central automation. AWS and its partners offer a wide range of tools and features to help you to meet your security objectives. These tools mirror the familiar controls you deploy within your own on-premises environments. AWS provides security-specific tools and features across network security, configuration management, access control, and data security. In addition, AWS provides monitoring and logging tools, which gives full visibility into what is happening in your environment. AWS provides several security capabilities and services to increase privacy and control network access. These include built-in firewalls that allow you to create private networks within AWS and control network access to your instances and subnets. For example, the security groups that we have covered in the earlier part of this course. Encryption in transit with TLS across all services. Connectivity options that enable dedicated connections from your office or on-premises environment to AWS, which are called AWS Direct Connect. DDoS mitigation technologies as part of your content delivery strategy. AWS offers a range of tools to allow you to move fast while still enabling you to design your cloud resources to comply with organizational standards and best practices. These include deployment tools to manage the creation and decommissioning of AWS resources according to organization standards, inventory and configuration management tools to identify AWS resources and then track and manage changes to those resources over time, template definition and management tools to create standard, pre-configured, hardened virtual machines for EC2 instances. AWS offers you the ability to add a layer of security to your data at rest in the cloud, providing scalable and efficient encryption features. Data encryption capabilities are available in AWS storage and database services such as Amazon EBS, Amazon S3, Amazon Glacier, Amazon RDS, and Amazon DynamoDB. Flexible key management options allow you to choose whether to have AWS manage the encryption keys or for customers to maintain complete control over their keys. AWS Key Management Service, or KMS, is a managed service that makes it easy for you to create and control the encryption keys used to encrypt your data. It is integrated with AWS CloudTrail to provide you with logs of all key usage to help meet your regulatory and compliance needs. Dedicated hardware-based cryptographic key storage options are available for customers to help satisfy compliance requirements. AWS Cloud HSM is a cloud-based hardware security module that enables you to easily generate and use your own encryption keys on the AWS Cloud, where you, the customer, owns the root of trust. In addition, AWS provides APIs for you to integrate encryption and data protection with any of the services you develop or deploy in an AWS environment. AWS offers you the ability to add a layer of security to your data at rest in the cloud, providing scalable and efficient encryption features. AWS Identity and Access Management, IAM, is a role-based access control service that manages administrative access to the AWS services available in the AWS account. Multi-factor authentication, MFA, adds extra security because it requires users to type a unique authentication code from an approved authentication device. With Federation, you can use single sign-on, SSO, to access your AWS accounts using credentials from your corporate directory. Amazon Cognito lets you easily add user sign-up and authentication to your mobile and web apps. It enables authentication of users through an external identity provider and provide temporary secure credentials to access your app's backend resources. AWS SSO is a service that makes it easy to centrally manage SSO access to multiple AWS accounts and business applications. With AWS SSO, you can manage SSO access and user permissions to all of your accounts centrally. AWS provides tools and features that enable you to see what's happening in your AWS environment. These include AWS CloudTrail that provides visibility into API calls, including who, what, when, and from where calls were made, Amazon CloudWatch logs for log aggregation and options, streamlining investigations and compliance reporting. Amazon CloudWatch alarms to send notifications when specific events occur or thresholds are exceeded. These tools and features give you the visibility you must have to spot issues before they impact the business and allow you to improve security posture and reduce the risk profile of your environment. What if you want to make use of the same tools you have been using in your on-premises environment on the AWS platform? The AWS Marketplace offers hundreds of industry-leading partner products that are equivalent, identical to, or integrate with existing controls in your on-premises environments, including anti-malware web application firewalls and intrusion protection. These products complement the tools and features offered by AWS to enable you to deploy a comprehensive security architecture and a more seamless experience across your cloud and on-premises environments. What is the AWS Shared Responsibility Model? After the customer starts using the AWS platform, AWS shares the responsibility of securing the data in AWS with its customers. This concept is known as the AWS Shared Responsibility Model. Let's take a look at what AWS is responsible for and what the customer is responsible for in this model. AWS is responsible for what is known as security of the cloud. What does that mean? Under the Shared Responsibility Model, AWS operates, manages, and controls the components from the host operating system and the virtualization layer down to the physical security of the facilities in which the services operate. It means that AWS is responsible for protecting the global infrastructure that runs all of the services offered in the AWS Cloud, which include regions, AZs, and edge locations. Protecting this infrastructure is AWS' #1 priority, and while you can't visit AWS data centers or offices to see this protection firsthand, AWS provides several reports from third-party auditors who have verified our compliance with a variety of computer security standards and regulations. Note that in addition to protecting this global infrastructure, AWS is responsible for the security configurations of its products that are considered foundational or managed services, which include compute, storage, database, and networking. Examples of these types of services include Amazon DynamoDB, Amazon RDS, Amazon Redshift, Amazon Elastic MapReduce, Amazon Workspaces. While the cloud infrastructure is secured and maintained by AWS, customers are responsible for security of everything they put in the cloud. When using AWS services, customers maintain complete control over their content and are responsible for managing critical content security requirements, including what content they choose to store on AWS, which AWS services are used with the content, in what country that content is stored, the format and structure of that content, and whether it is masked, anonymized, or encrypted. Who has access to that content and how those access rights are granted, managed, and revoked. Who has administrative rights to the AWS services available in the AWS account. Customers get to retain control of what security they choose to implement to protect their own data, platform, identity and access management, applications, and operating systems. That includes patching their guest OS and applications. This basically means that the shared responsibility model changes depending on the AWS service the customer uses. One of the key AWS security services is Identity and Access Management, which is the next service we are looking at. AWS IAM is a service that helps you securely control access to AWS resources for your users. You use AWS IAM to control who can use your AWS resources, this is known as Authentication, and how they can use resources, known as Authorization. AWS IAM allows you to manage access to compute, storage, database, and application services in the AWS Cloud. In short, this is the role-based access control or RBAC mechanism to manage access on the AWS platform. Think of the access control concept you are already familiar with, such as users. Think of these as your end users. Groups, think of these as a collection of users by job function. Permissions, which can be applied to users or groups. And roles, think of these as trusted entities. That's exactly what AWS IAM uses, which makes it so powerful. Using AWS IAM, you can create and manage AWS users and groups and use permissions to allow and deny the access to AWS resources. Let's take a closer look at IAM functionality. AWS IAM allows you to, firstly, manage AWS IAM users and their access. You can create users in the AWS IAM, assign them individual security credentials, in other words, access keys, passwords, and multi-factor authentication devices, or request temporary security credentials to provide users access to AWS resources and services. You can manage permissions to control which operations a user can perform. Next, manage AWS IAM roles and their permissions. You can create roles in AWS IAM and manage permissions to control which operations can be performed by the entity or AWS service that assumes the role. Finally, manage federated users and their permissions. You can enable identity federation to allow existing identities like users, groups, and roles from your corporate directory to access the AWS Management Console, call AWS APIs, and access resources without the need to create an IAM user for each identity. When you first create an AWS account, you begin with a single sign-in identity that has complete access to all AWS services and resources in the account. This identity is called the AWS account root user and is accessed by signing in with the email address and password that you used to create the account. Because you can't restrict permissions for root user credentials, it is recommended that you delete your root user access keys. If you require administrator-level permissions, create an IAM user, grant that user full administrator access, and then use those credentials to interact with AWS. If you need to modify or revoke your permissions, you can delete or modify the policies that are associated with that IAM user. When adding users, you get to select how users will access AWS. There are two different types of access you can assign users: programmatic access and AWS Management Console access. Programmatic access enables an access key ID and secret access key for the AWS API, CLI, SDK, and other development tools. The other option is to give AWS Management Console access to users, which allows them to sign in to the AWS Management Console. The AWS Management Console provides a simple web interface for AWS. You can log in using your AWS account name and password. If you have enabled AWS multi-factor authentication, you will be prompted for your device's authentication code. After a user has been authenticated, they then have to be authorized to access an AWS service. To assign permission to a user, group, or role, you have to create a policy, which is a document that explicitly lists permissions. It is important to note, as depicted in the diagram, that one policy can be assigned to an IAM user, IAM group, and IAM roles. On the AWS Management Console, we click on IAM to the left of your screen. On the AWS IAM console, we have a few options to choose from. Let's click on Policies. Here, you see the AWS Managed Policies. Let us create a policy using the AWS Policy Generator wizard. We start with the Allow option and choose Amazon S3 under AWS Services. Under Actions, we could allow all list operations. Rather than selecting all the list operations, let us select one for now and update the policy later. Under Amazon Resource Name, we use the wildcard character. On the Amazon S3 console, we have a bucket which contains a folder labeled Public. The folder contains a picture, and the same picture is also stored on the root of the bucket. Let's create a second statement in AWS IAM for Amazon S3. Under Action, let's choose the GET object operation to permit download. For Amazon Resource Name, or ARN, let's follow the documentation to learn more about the structure. The ARN always starts with ARN, followed by AWS, and a service in use. In our example, we will use S3, followed by the bucket name, /folder, and /star to indicate all objects under the policy. Now let's create a statement for Amazon EC2. Under Actions, we will select all Describe and Get actions, along with the options to start and stop instances. Finally, under ARN, let's use star to indicate all instances and click on Next Step. Let's give the policy a name, a description, and let's replace S3:list bucket with S3:list star, which indicates all list operations. We then validate the policy and create the policy. The policy can be listed using the Customer Managed filter. Let's create a group called Team1 and attach the policy we created earlier. After we create the group, we proceed to create users. Because the user 1 will only need console access, we select the appropriate option. The user is provided with the password and now can be prompted to enter a new password if needed. We now add the user to the group, making sure they have the right permissions. Login details can also be emailed to the user. For this example, we will copy the login URL and use another browser to simulate the new user login. Notice the AWS account is specified and the user only enters the login credentials. After logging in, let's go to the Amazon EC2 console and then to the Instance option to find the list of instances. If the user tries to terminate an instance, they get an unauthorized error message. However, if the user tries to start an instance, As per the policy, it should be successful. Similarly, a stop operation should also be permitted. Let's now move to the Amazon S3 console. As per the policy, the user should be permitted to list all the buckets and their contents. But any option to download objects should fail unless it is a public folder in the demo bucket. Any option to download an object in the bucket also fails unless it is the public folder. As expected, the picture was successfully downloaded. Now that you have seen how AWS IAM works, let's walk through some of the best practices of AWS IAM. Delete your AWS root account access keys because they provide unrestricted access to your AWS resources. Instead, use IAM user access keys or temporary security credentials. Activate multi-factor authentication, or MFA, on your AWS root account to add another layer of protection to keep your account secure. Create IAM users and give them only the permissions they have to have. Do not use your AWS root account for day-to-day interactions with AWS, because the root account provides unrestricted access to your AWS resources. Use IAM groups to assign permissions to your IAM users to simplify managing and auditing permissions in your account. Apply an IAM password policy to require your IAM users to create strong passwords and to rotate their passwords regularly. Use roles for applications that run on Amazon EC2 instances instead of storing credentials in the instances. Delegate by using roles instead of by sharing credentials. For example, this can be used to temporarily grant access to an IAM user from AWS account A to AWS account B without having to create another IAM user in account B. Rotate credentials regularly. Remove unnecessary users and credentials. Use policy conditions for extra security. For example, you can restrict certain actions that modify or delete existing settings to only when the login is via MFA. Lastly, monitor activity in your AWS account using AWS CloudTrail.